Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about plotting the graph of linear equations in two variables by using the slope and the y-intercept. In my previous video, I had presented to you about plotting the graph of linear equations by using the x and the y-intercept. So this time, I will be teaching you on how to plot the graph of linear equations in two variables by using the slope and the y-intercept. So before we go to our examples, let us have first the general form for linear equations in two variables, which is ax plus by equals c. And from this general form, we derive the slope-intercept form, which is defined by this function y equals mx plus b, where our m is the slope and the b is our y-intercept. The slope is defined by the rise over run. And of course, the b is the y-intercept. When we have the y-intercept, our x is always equal to 0. So to proceed to our example, for example, you are told to plot the graph of this equation, y equals 3x minus 5. Now, since this equation is already in the slope-intercept form, y equals mx plus b, our m here, which is the slope, is equal to 3, or since this is a whole number, it is assumed to have a denominator 1. So that's why we will have 3 over 1. So our rise is 3 and our run is 1. And the b, which is the y-intercept, is equal to negative 5. This is our b. Since this is a y-intercept, so our x is equal to 0. So if we have the y-intercept, x is always equal to 0. And if we have the x-intercept, y is always equal to 0. But in this video, we will be talking of the y-intercept. That's why our x is 0 and our y is negative 5. Now, since we already have the m, which is 3 over 1, and the y-intercept, which is 0 and negative 5, we will plot first the y-intercept in the Cartesian plane. So we will have, if this is our Cartesian plane, look for the point 0 and negative 5. If this is our x-axis and we have here the 0, then our y value is negative 5. So we have here our negative 5. So therefore, this is our first point. Now, how do we go over with the rise over run? Our rise is positive 3 and our run is positive 1. And since our rise is positive 3, so we will go 3 units upward and 1 unit to the right since they are all positive. Now, if the rise is negative, so we will go units downward. So since this is positive, so we start with the y-intercept, which is 0, negative 5. We count 3 units upward, so we will have here 1, 2, and 3. Then our run to the right is 1 unit, so 1. So therefore, this is our first point. Now, as I have mentioned in my previous video, we only need at least 2 points in order for us to plot the graph of linear equations in two variables. So 2 points is enough, so we'll just simply connect these 2 points, and that is now our line. But if we want to continue plotting the points, so we can still do the same. So we can do the same process. We count 3 units upward. So we have here 1, 2, and 3. Then 1 unit to the right, we have 1. So this is our third point. We have these points. Then by connecting these 3 points, we can have this line. So this line is now the graph of the equation y equals 3x minus 5. Okay, let's proceed to our next example. For example, you are to plot the graph of the equation 2x plus 3y equals 6. Now, as you can see, the equation is in the general form. 2x plus 3y equals 6. So what we need to do is we need to change this general form to slope-intercept form, which is y equals mx plus b, for us to determine the value of the slope and the value of the y-intercept. So how do we do this? We have to see to it that what remains at the left side of the equation shall only be y. So therefore, we need to eliminate 2x here so that what remains at the left side of the equation shall only be y. So how to eliminate is just by simply using the subtraction property of equality. So we subtract 2x here so that we can cancel this out, And of course, since this is subtraction property of equality, we will also subtract 2x at the right side. So in this case, we can cancel out the 2x. 2x minus 2x is 0, or this is cancelled out. So what remains now is the 3y. Then we can arrange by following the form y equals mx plus b. So what comes first in this equation shall be negative 2x, then followed by the constant, which is 6. Now, since we have the coefficient of y here, which is 3, we need to divide by using division property of equality. We need to divide both sides of the equation by 3. So we can cancel out the 3. So what remains at the left side shall be the y. Then, negative 2x over 3, we copy. Since we cannot divide 2 by 3, we just simply copy negative 2x over 3. Then, 6 divided by 3 is 2. That's why we have here the 2. So we have now the slope-intercept form, which is y equals negative 2x over 3 plus 2. So to identify our m, our slope is negative 2 over 3. And of course, our y-intercept is 2. And for the point, we have 0 and 2. Our x is 0 and our y is 2. Now, we will be using this slope and this y-intercept to plot the graph of this equation 2x plus 3y equals 6. So, if this is our Cartesian plane, we look first for the point 0, 2 in the Cartesian plane. So, this is our x-axis, which is 0, and our y is 2. That's why this is our first point. Now, since our rise is negative 2, so we need to move 2 units downward. Unlike with the first example, since our rise is positive, so we move 3 units upward. But this time, since this is negative 2, so we move 2 units downward. So this is 1, 2. And our run is 3, which is positive, so we move 3 units to the right. So 1, 2, and 3. So this is our second point. And if we want to continue, so the same process, we have 1, 2, and 1, 2, and 3. So this is our third point. We now have this point. We connect these 3 points, and this is now the graph of the equation 2x plus 3y equals 6. Now let's proceed to our last example. For example, you are told to plot the graph of this equation, x plus y equals 1. So the same process, we need to eliminate the x so that only y shall remain at the left side of the equation. So we subtract by using subtraction property of equality. We subtract x here. Of course, we will also subtract x at the right side. This time, we can cancel this out. So what remains now is the y. Then we arrange our negative x shall come first, then plus 1. Then this time, this is now the slope-intercept form, y equals negative x plus 1. We will now identify our slope. Slope, therefore, is negative 1. So this is negative x, it has assumed coefficient 1. That's why we have here negative 1. Or, assume denominator 1, so that's why negative 1 over 1. Our slope is negative 1 over 1. Then, of course, our y-intercept is 1. The ordered pair shall be 0 and 1. Plot the point 0, 1 in the Cartesian plane. So we have here x is 0 and this is our y, which is 1. So this is our first point. Then, for the slope, which is negative 1 and 1, so we move, since the numerator is negative 1, so we move 1 unit downward. So from this point here, we have 1 and 1 unit to the right. So this is 1. So this is our second point. Then the same process, we move 1 unit downward and 1 unit to the right. So this is our third point. By connecting these points, so we can have this line. So this line is now the graph of the equation x plus y equals 1. Okay, that's it. I hope you have learned something from this video. Please do not forget to subscribe, like, and share to your friends. Thank you and God bless.